conclusion. Okay, now we can record. All right, so here's the thing we're gonna do over here. And as you can see, I can barely see my screen here. I'm gonna control minus over here to get all of this running. We're about to do a bunch of even and odds. And let me just do this like this. Even and odds playthrough. And I'm trying to get my tablet working. And hopefully I find my... Ooh, I find my little bit of a... Yeah, I almost lost this. Anyways, we're gonna go to home over here. And sorry, we're gonna do even and odds. We're gonna explain each one. I think they're self-explanatory. Uh, yeah. So nowadays I'm going to LaTeX and back to Google Docs. Becoming a pain. I might change everything to Google Doc. I don't know, LaTeX later on because I realize LaTeX is kind of the future. And right now my tablet's not working, so we're just waiting around a little bit. But then again, 500 pages. Maybe Google Docs would be nicer. Yeah, it's taking a while. So, what I've been doing is after the last episode, I noticed that even though it was like one line, and I just said, nah, that's not enough. So we have conducted a bunch of even and odd things. Okay, looks like looks like I'm gonna have to change my plan. Instead of doing it this way, we're gonna go over here. And we're just gonna change this to 100%. Okay. And we're just gonna hope wherever I have done, however, wherever I see that, hopefully nowhere near. We Okay, that's where we are. Okay, so all right. So somewhere over here, we're gonna go over here. And then this is where we're gonna write, hopefully, with a pen length of 2. Um Let me erase all this. The reason is my tablet's not really getting the internet correctly again, which means I can't use a new tablet. Anyways, so we're gonna start with what the even is. Even. Okay, so even over here, as you can see now, is much more clean. Even is 0, comma 2, comma 4, comma 6, comma 8, all the way up to 2n. Odd is basically 1 comma 3 comma 5 comma 7 comma 9 comma 11, which can be defined as 2n plus 1. N is the integer, which we will say it contains all integers possible. Maybe I should have wrote that over there, but it's kind of self-explanatory. Whenever there's the n, usually it means integers, but I guess over here I haven't really showcase that it really means all of it. So I should have, in my haste of doing this, I did not think to do this. Let me go to insert. Be careful. Okay. Z, none of them work. Let me just try Z again like this. There you go. There is the weird Z that's necessary for all real values of that thing to indicate. I don't remember what it indicates, but it indicates something that is very important to what we're trying to do. So the first thing we do is even plus even equals, I believe, even, which is true. It is even. That is true. And we can this mic is shit, isn't it? It's not really catching my audio often. It's like monitoring it a little bit. So we're gonna say a equal to k and b equal to l. The reason I'm not using n is because then it's just n plus n, which will defeat the whole purpose. And we're doing n as a generalization, so we're not actually using n over here. But as you can see, k is also z, and l is also contained in all integers. This means belongs to, basically mean the domain. Uh, I didn't know that for a long time, and it was like confusing for me. Anyways, I didn't get taught that until college, which is weird. You should have. I think you should have been taught that like when you were younger. Anyways, we're over here now, right? So, when you're adding this, you see you're looking for even. So even is defined by 2k, no, 2n, right? So I mean easily. So we just have to do a plus b, where there's a container, and then 2k plus 2l. These are two different integers moments, but once you get k plus l, we understand that we can get this as same thing equivalent to n, in this case n. The reason why we say that is, let me see, 0 plus 1 equals 1, and then you can just keep on flipping it to get all the integers around everywhere. So that's the reason why. And then 0 plus 1 or 1, so you could think of it as like, if this starts at 0 and this starts at 0, well, that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if you add these up, eventually you get a new row with all the integers again. I don't know if I'm saying it correctly. Probably not, but you get the point. Basically, the integer is a bigger, I guess, domain of integers if you make it finite, if you make it infinite or something. I don't know. But basically, it's k plus l equal the same thing as 2n n s, just another well, bigger integer collapse in there. Yes, so it will always be even. It'll be a bigger integer and it'll be even. Right? Right. Oh, why is it not working again? Oh my god. Bigger integer, right? Bigger integer. It'll be a bigger integer, and that's all you'll find. Oh my god, this mic is awful. Okay, maybe I should change this mic and just use this because I don't know what's going on with this mic. Anyways, we get the general idea, and we're just gonna run through the rest of it. Basically, when we're odd, we just have we'll just change it to have a equal to 2 uh k plus 1, and then b equal to 2l plus 1. And here we'll say a plus b, and then you get the drift. It's just 2k plus 1, and then plus 2l plus 1, which is, you get the drift, right? You get the drift? Yeah. So it's 2 parentheses k plus l plus 1, which can be simplified as, wait, this is even. This is even. This is even. And we can simplify that to even because 2 multiplied by 1 is 2. So odd plus odd is even, which makes sense. Think of 3 plus 1, that equals 4, and then so on and so on. I almost messed that up immensely. I messed that up so badly almost. Uh, even plus odd. So even plus odd, which is would be 2k plus 2l plus 1, right? Right, right. And then this will equal, let's see, 2 parentheses k plus l parentheses plus 1, and you know that this is an integer, so it's 2n plus 1 basically. Done. So even and odd will get you basically odd. Next would be product of odd. So product of odds is 2n plus 1, and then 2, no, you can't use n because that's the final digit I'm using. 2 parentheses k plus 1, then parentheses 2l plus 1, And then this goes like this, so you can kind of see where I'm going with this. 4K. Oh, wait, I forgot I didn't teach you anything about um how to expand yet. Oh, damn. Oh well. I'm showing it, so it doesn't really matter, right? It's just expanding. We'll explain this later. Um, uh, well, this is a little bit of a more advanced topic then. I can't really. Wow, 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 wow. Okay, let me change this real quick. Fudge. Where's the expand polynomial section? Oh, darn me. So I'm just gonna move this up over here. And then move. I know this seems so scummy to do. Don't worry, I'm not gonna delete it from that section. Where's my? I think it's up here. Right? No. I always forget the beginning section because I only go back to it if I want to add something really insane and really cool to it. And here, I think it's pretty cool to add. Oh, that's really big. Okay. And then we'll just say between. Oh, where's the between button here? Okay, I royally screwed up, but we're good. We're saved. And it may look small here, but in reality, that's because I'm zoomed out like insanely. It should be good when it comes to printing, but we could always do this way to make it cleaner. Um, yeah. Okay. I did not expect that. I forgot about that entirely. And this mic is becoming a little bit of a problem. Okay. It's like spiking for no reason. I don't know why. Anyway, problem solved. I give up. All right, this mic is a shit show. Let me just. No, I'm not. I'm not dealing with that bull crap. This mic is like giving me multiple problems. All right, we're not using that. All right, because it's just a mess. I don't know what's going on with the mic. The webcam also is giving me problems. So if it keeps on giving me problems, I'm deleting that too. Anyways, this is 2poo-k plus 2l plus 1, and we see that 2kl plus k plus l plus 1. And this, as we know, is just n because it's a multiple of 2, but integer multiplied by 2. Just showcasing here. 0, 2, 4, 6, and so on. So. It's just even, right? And even multiplied by more even will just give you even. Again, it's just not anything. Uh, by the way, integers can be negative, so in this case, this could be a -1. Why is that important? That just allows you to have the full n domain of the, it's not really that important. But if it wasn't that, I would gesture that it might not work for every single integer. Like so I don't know. I will have to test that out, but it may not be every integer. Hmm. I don't know. Well, actually, I just figured it out with math, and right now it's like 11, 10, and I don't have the brain capacity to think. I'm just explaining all this. That's all I'm doing. I'm not thinking. I'm just explaining. Now we have, oh my God, I flicked it again. Okay, even, and it's a product this time, which is quite fun, and I don't like how we did it. We'll just say it's a product by my voice. So we know A times P basically is this time is even, so A equal 4K, and you know what the drill. Maybe not because it's attention span. We're doing basically we're doing 2K parentheses 2L, which means even multiplied by even, which is 4KL, which we know is even. But do we know if it contains all the original characters? Now, I do wonder, I said I'm not going to do this, but why not? This originally contains all evens, basically. This is basically already 2n, and you multiply by 4, 2 by it, which basically is just 4n, and it contains all integers, right? So that is n equal 1, and it's also negative, negative 1, 0, comma, 1, comma, 2, comma, 3, and under the 4 tenths, it is this, which means that it is even, but it does not contain all even numbers. It's just even. Yeah, so there we go. There's your proof there. Uh, well, that was quite, hmm? That was quite eventful, and kind of actually already knew that. I just wanted to confirm to the audience. Um, why would it's a bad ABC? Oh, not again. Please, please. Sometimes when I do that, it does something freaky. And I'm realizing that the webcam is having troubles. All right. Right, screw the webcam. We're going oldie. Okay, so all right. So we're doing if A equal 2K and B equal 2L, A minus B equal 2K minus, oh, this is just the same thing, but just minus. You get the same shenanigans, basically no difference at all. Um, it gives you even also, but you also get a K minus L, like 2. And this is an integer. So 0, 1, 2, so. You can basically get all integers by the combination of two integers. So the binary contains all these. It doesn't have any weird catch. Um, although the earlier one did not have any catch too. It's all integers either. So, just to be clear, when I write n, I mean all z, no matter what the case is, no matter what. Um, In this case, sorry, if it's a for loop and that's something else, it's maybe not that. Uh, sorry, not for loop. Some weird function that I will probably do later. I don't know because my math notation is god awful. My nomenclature is awful. Yes, I know. So next is the difference of odds, which you kind of get the same thing. It's even, and you kind of get why, right? The set is literally, I mean. The ones just cancel out, basically. It's I will explain. Minus 2L plus 1. You see this thing cancel out, so you just get 2K plus 2 minus 2L, which is 2 parentheses K minus L. It's the same thing with addition, but you just have a difference in sign, literally. Okay, next. We have this one, which is a difference of an even integer and an odd integer is odd. So even minus, basically the same thing again, just opposite sides. I think you get the point here, but basically this is 2K minus the odd version, you know, which equals 2 parentheses K minus L minus 1. And you can kind of see that this is n, so it's 2n minus 1. Oh my God, my handwriting got shit on that one. Okay, maybe I should be more focused on this one, but you get the point on that one. I want to hurry up to the actual interesting one. So here's an interesting one where actually it's not really that interesting. And then after this, we're done with the cases. Basically, here are some cases that are that you know kind of more like yeah, yeah, can yeah, like you can think of, but less proof, more like yes, it's proof, but you already know this. Kind of if you check out even numbers, if you play around it with long enough. The last two maybe not, but you get the point. Last two, I mean, okay, you kind of get it. So here's the thing about the last two. If you play with even numbers, as a lot of people do when you're kids, and then you say, "Oh, I forgot odd multiply even." I'm gonna have to do that. Uh, I'll do that later. Odd. So if you do odd, let me see what we'll get. Multiply even. Basically, it'll be 2L plus 1. It would just be doing this, which is probably gonna be even, honestly. But um, oh no, it's not good. No, it's gonna be a new polynomial. Oh, right. I'm gonna have to figure out a new thing. Whatever. So this is odd, just to be clear. Um, uh, but it's interesting nonetheless. So the last one, if you played around with it a little bit like this, and you played around with the odd numbers, three, not three, five, and then you play around, you can see 0, 4, 16, and 36, and then you can play around with this 9. This is what is even this? 525, sorry. The 7 is 49, I think. Yes. If you play around with this, you can kind of get a pattern, and from that pattern, you can reverse engineer this fact one way or another. So there's multiple ways to get this. Um, but the easiest way to get this known fact, and my eraser's no longer working. Great. I love living those, man. They're the peak of uh, uh, tablets of biology. Okay, let me just do a scan then. Maybe this will help more. Yeah, that was easier. Okay, so you can get so you can get A equal 2k plus 1, and you can say 2k plus 1 square. Okay, you got that? Oh, I forgot to change that N to an A. Oh well, doesn't matter. I'll just leave it there because it doesn't matter at this point. I'm too lazy to fix it. If that is 4k squared plus 4k plus 1, which equals 8 parentheses k parentheses k plus 1 divided by 2 plus 1. And this is m in this case. And then we go to the next one where we say a equal to k, and then this is 2k squared, which equals 4k squared. That's how you get it. And that's how you get everything. That's the last two patterns. I'm done. And let me go to overleaf later and change all that shenanigans to the right letters. And, yeah, oh, right, I forgot the last question, which is the actual proof part. This was like more like statements, which is why I was okay with doing it overleaf. Because I mean they're questions nonetheless, but I guess I guess you're right. No, they're questions. I should have done it. I mean, maybe I don't. But anyway, the next one is prove that any two consecutive. So consecutive. Actually, you're right. No, those are all questions. There, good. So 2n plus 1, and then plus 2n plus 3. N is contained by all of these. And then from this, you get 4n plus 4 equal 4 parentheses n plus 4. And you can see clearly over here that it's divisible by 4. Therefore, the proof checks out. Yeah. See over there? That is definitely true. Anyway, we're done now.